going to be working the problems here from, let's see, what section are we in? 2.4? Yeah, 2.4, product and quotient rules. And just going to remind you that I do it a little different than the book does it. So throughout my explanations here, I'll be using the product rule. Try and find a good marker here, which says that if you have the product of two functions, f times g, the derivative will be f prime g times g plus g prime f. And then the quotient rule says that if you have f divided by g and you need to take the derivative, it's f prime g minus g prime f all over g squared. So those are the rules I'm going to be using. That's the format of the way I'm going to be using them. And yeah, let's do it. It's Monday morning, all right? So cut me some slack. I had a good weekend, so I'm a little tired today. All right, so number one, find the derivative of, they give you f of x equals parentheses 1 plus 2x squared times x minus x squared. They say find this doing it two different ways. First of all, the product rule, and then the other way is just to multiply it out and take the derivative. So what I notice first of all is that this function f is the product of two functions. And I could use f and g again, but it's already called f. So I'm going to call this the g function here. That's everything here. This is like my h function. So I'm just using two different letters since f is already used. And so taking the derivative of f is equivalent to taking the derivative of g times h, but by the product rule, this should be g prime h plus h prime g. And so if I write this out slowly, all right, since this is our first problem, I'll say f prime x is going to be the derivative of g, so it's going to be the derivative of this, right, times h, so h without any derivative, plus the derivative of the h, so the derivative of that, times the g without a derivative. All right, so there it is. Now I'm just going to take the derivative. So if I just focus all my attention right here, the derivative of this is going into the last section. Derivative of 1 is 0. Derivative of 2x squared is 4x. Then times this. Plus, now the derivative of this is going to be, in parentheses, derivative of x is 1. Derivative of negative x squared is negative 2x. And then times 1 plus 2x squared, like that. And that's it. That's the derivative. I could come through and clean this up. I could distribute through here. I could have 4x squared minus 4x cubed. And then here I could multiply this, expand this out. I would get plus, let's see, 1 plus 2x squared minus 2x minus 4x cubed. So that's what I get when I multiply all that out. Then I could collect like terms together, and it looks like I'm going to have negative 8x cubed. That took care of those. And then x squareds, I have 4 of them and then 2 of them, so 6x squared. Done with those. And then I have a minus 2x, and then I have plus 1. So that would be my derivative. Now that's doing it the first way. The other way they suggested was just to show you that without using the product rule for this problem, we could still get the same answer. So why don't we start in the very beginning and just distribute. So forget the g and the h, just multiply this out. You'll get x minus x squared, let's see, plus 2x cubed minus 2x to the fourth, like that. And if I take the derivative of this, okay, so take the derivative of that using last class, derivative of x is 1, derivative of this is negative 2x, derivative of this plus 6x squared, and then minus 8x cubed. And that matches up with that, so we get the same answer. Now, I would argue that this is probably a little easier, but there are going to be problems where we can't do this, and so it's worth our while to know the product rule, as you'll see as we move on. All right, number 2. Sorry, I forgot to put that was number 1. Number 2. Find the derivative of the function capital F of x equals, all right, x to the fourth minus 5x cubed plus root x all over x squared. And I believe they want us to do it both ways. So again, we can actually simplify this one and do the derivative, but let's do the quotient rule first. Let's realize that we have a function on top divided by a function on the bottom. Since this is capital F, I'll call this little f up here. That's this entire numerator. And then this right here is our g. So if I want to know what the derivative of capital F is, that's the same as taking the derivative of little f over little g, which is f prime g minus g prime f all over g squared. So for us, in this problem, the derivative of capital F will be, all right, the derivative of f, which is the top, I'm going to say it's the top, the numerator, that derivative times g, which is just the bottom, times g, which is x squared. I can just leave it like that. I don't need it in parentheses because it's a single term, minus the derivative of the bottom, which is going to look like that, times the top, which is x to the fourth, minus, let's see how we're doing on the camera space here. I can go, okay, minus 5x cubed plus root x, that's f, without a derivative. All of this, the entire thing, over g, but then squared. All right, now let's take some derivatives. So the derivative will be, okay, I need the derivative, right, of this. So derivative of first term is 4x cubed. Derivative of this is negative 15x squared. Derivative of the square root of x is 1 over 2 root x. That one's a real quick one. And then all times x squared. Okay, so there's multiplication through all those. Minus, now the derivative of x squared is 2x. Then times x to the fourth minus 5x cubed plus root x. All of this over x squared squared, so x to the fourth. And that's our derivative, okay, what we call kind of like the raw derivative, but now let's clean it up. Let's multiply x squared through these three terms. So we'll have 4x to the fifth minus 15x to the fourth. And then when you do this on top, you're going to get x squared over 2 root x, right? That's what you get when you multiply here. Remember that root x, same as x to the 1/2, and then you subtract the exponents. 2 take away a half is 3 halves. So we're going to get, was it plus? It was plus. I'm going to write 1/2 x to the 3 halves. That's what I'm going to write there. That takes care of the distribution here. Now I'm going to distribute through here, negative 2x times this. So we get negative 2x to the fifth, positive 10x to the fourth. And then finally this times this, we get negative 2. And remember, we're multiplying x times root x times root x, the same as x times x to the half. Add the exponents, you're going to get 3 halves again. Hold on a second. Yeah, 3 halves. Okay, so x to the 3 halves. And then all of this over, that's a 2. X to the 4th. My goodness, what a mess. All right. Now, let me combine like terms on the top. I have 4x to the 5th minus 2x to the 5th. That's 3x to the 5th. To the 4th, I've got minus 15 and plus 10, so minus 5x to the 4th. So I've taken care of this, 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 this. I have plus a half x to the 3 halves minus 2x to the 3 halves. Those are like terms. Take 1/2, subtract 2, you get negative 3 halves. X to the 3 halves. But it's all of this over x to the 4th. And now, one last step. I'm going to split this up into 3 separate terms. Man, I'm hungry. All right, I'm gonna get, so it's gonna be this over this, this over this, this over this. So this over this, I just get 3x. This over this, the x to the 4th cancel, minus 5. And then this over this, let me see, I'm gonna have negative 3 halves out front. Then I have to take 3 halves and subtract 4. So 3 halves subtract 4 is the same as 3 halves subtract 8 over 2. That's gonna give me negative 5 halves. So x to the negative 5 halves. And you could, of course, drop that down, but I'm just gonna leave that like this right now. Okay, now that's our answer. Now they say to check it the other way too. The other way would have been to, man, I don't feel good. I'm not sure what's going on with me right now. I feel a little dizzy. Okay, the other way would be don't take the derivative, just split it up first. Just rewrite it. This over this, this over this, this over this, then take the derivative. So we would have had x squared minus 5x and then plus x to the, remember this is x to the half here. X squared, you go 1 take away a half is, 1/2 take away 2 is going to be x to the negative 3 halves. And then we take the derivative. So, something is off. Something's off. But let me take derivative. Here we get 2x, here we get minus 5, and here the negative 3 halves comes out. We subtract 1 from that, get negative 5 halves. This is good, this matches, something's off here. I'm gonna have to go back and look at my arithmetic to see that that should have been one of these. I think this one should be a 2, but I'll go back. So I'm kind of feeling a little wobbly up here right now. All right. Let's look at number 4. Okay, so number 4, we get f of x is square root of x sine x. So we notice here that we have a product right there. There's a product occurring right there. So we can't do what we did in number 1 where we just distribute everything through and kind of bypass the product rule. We have to use the product rule here. So we can look at this as being like a function g times a function h. And I could write the formula out, but what we're going to kind of get used to doing here is this. We're going to say when you have a product, it's going to be the derivative of the first one times the second one plus the derivative of the second one times the first one. All right? So it's like this is your g prime h plus h prime g. All right, so derivative of root x is going to be 1 over 2 root x times sine x plus derivative of sine x is cosine x times root x. And this is about it. I mean, we can mess with this algebraically, try and get a common denominator. I am going to put the root x out in front of the cosine x because some people will think you can put these together. You can't. This is the argument of cosine. This is multiplied times the entire cosine function. So you can't put these two and multiply them. You have to just put this out front. So that's it. If I wanted to get a common denominator, I could put 2 root x down here and 2 root x up here. And when I multiply this 2 root x, I have to multiply it times the front there. So I would get sine x plus this times this would be 2x cosine x, then all over 2 root x. I could do that, but the other answer here without this blue would have been okay. We just need to be able to get a common denominator. That may come into play later on. All right, so that's it for number 4. Let's look at number 5. Capital F of y, so they're using a different variable here, is 1 over y squared minus 3 over y to the 4th times y plus 5y cubed. Now if I were doing this, I would probably multiply those two out, just multiply them out and do it using what we learned last section. But I'm going to show that we can use a product rule here, because there's a product. I'm going to first rewrite this as y to the negative 2 minus 3y to the negative 4 times y plus 5y cubed. All right, so the derivative of this, f prime of y, should be the derivative of this first one times this one plus the derivative of this one times this one. So I'm going to write that down. Y to the negative 2 minus 3y to the negative 4 prime times the second one without any derivative plus y plus 5y cubed prime times the first one, y to the negative 2 minus 3y to the negative 4. All right, so that's our product rule there. Now let's actually take some derivatives. I'll erase this. Okay, so derivative of this here is going to be just the power rule from last class. So negative 2 comes out, subtract 1. So we get negative 2y to the negative 3. Now negative 4 comes out, that becomes a plus 12, y to the negative 5. And then here, nothing happened. Plus, now derivative of this, which is 1 plus 15y squared. And then nothing happened to this one. Y to the negative 2 minus 3y to the negative 4. And at this point, we can try and clean it up. We can distribute through here like this, and do the same thing here, and then try and collect all like terms together. I'll leave that to you. I'm just showing you what you'd need to do. The goal is to try and match the answer in the back of the book with your answer. All right, let's look at number 7. Sine x plus, so f of x is sine x plus 1/2 cotangent x. So I don't see a product here, neither should you. This is addition. I can just do derivative of each one, and each of those is something that I should know from last class. Derivative of sine of x is cosine x. And then the 1/2 is attached here. It's just going to come for the ride, so 1/2. And then the derivative of cotangent x. It's actually negative cosecant squared x. So I'm just going to put times, and in parentheses, the derivative of that, which is negative cosecant squared x, like that. And then I can go one more line, change this minus, bring that negative out and make it minus 1/2 cosecant squared x. That's it. So there wasn't any product rule or quotient rule here at all. Now, I'm gonna do number 9, even though it's not assigned. I think number 9 is a good one. You have h of theta, so they're using a different variable here, equals theta cosecant theta minus cotangent theta. Now, the reason I kind of like this one is because you have a product right here. This is a product, and this is a variable, not a constant, so it's not just attached, it's not just going to come along for the ride. This is like x. And because of that, we have to apply the product rule there. Now this right here, there's no product, so we're just going to take derivative of this straight down, but we will need the derivative on that part. So the derivative of h should be a product rule here, which is the derivative of the first one times the second one, plus the derivative of the second one, here it is, times the first one. So there's your product rule on that. Then minus the derivative, just the derivative of cotangent theta, all right? No product rule or anything. So what is the derivative of theta? Well, that's like saying what's the derivative of x, and that's 1 times cosecant theta, plus, now the derivative of cosecant theta should be negative cosecant theta cotangent theta, so you gotta look that up, negative cosecant theta cotangent theta, but then times theta still. And then you have the derivative of cotangent theta, which is negative cosecant squared theta. All right, that's pretty much it. This is cosecant theta. This theta right here comes out front, minus theta cosecant theta cotangent theta. And then right here, a minus minus becomes plus cosecant squared theta. And that's it. You notice that they all have a cosecant in it. You could factor a cosecant out, but I'm just going to leave it like that. All right, let's look at number 12. And let me also see what this was on my phone here. Nothing. Capital G of x equals x squared minus 2 on top over 2x plus 1. All right. Now you cannot split this up like we did like number 2, where you could split it up and skip the quotient rule. You have to use a quotient rule here. So your numerator here, I'm going to call this f, little f, call this little g, so we have a quotient. So the derivative, remember, if you have f over g, the derivative is this. Okay, that's what we wrote down earlier. So the derivative of g, capital G, is the derivative of f, which is the derivative of the top, times the bottom. I need the bottom in parentheses because it's 2 terms, minus the derivative of the bottom, here's the bottom, times the top, I need it in parentheses because it's 2 terms, all over the bottom, 2x plus 1, that quantity is squared. So here's your f prime g minus g prime f all over g squared. And then this is, derivative of this is just 2x, right? Derivative that's 2x, derivative that's 0, times the 2x plus 1, minus, now the derivative of this is just 2, times the x squared minus 2, then all of this over 2x plus 1 squared. And we are not going to expand that out, we're just going to leave it. And I will distribute. When I do that, I get 4x squared plus 2x and then minus 2x squared plus 4 all over 2x plus 1 quantity squared. That looks good. I can combine some like terms. I get these two become a 2x squared, and then plus 2x plus 4 all over 2x plus 1 quantity squared. And that looks like it. Do not believe that this will factor. I think you'll be stuck there, so just leave it like that. All right, look at number 14. I encourage you to do all these problems, like do number 10, do number 11, do number 13. I'm just doing the minimum of what you should do here. 14. Okay, a little bit of a change in notation. It's just y equals x plus 1 over x cubed plus x minus 2. Again, you see a quotient there, right? Here's your quotient. So I'm going to try and do this one without writing down like the f, g, and all that stuff. I'm just going to try and use what I've memorized here. The derivative of a quotient is going to be the derivative of the top times the bottom minus the derivative of the bottom times the top all over the bottom squared. So derivative of the top times the bottom minus the derivative of the bottom times the top all over the bottom, that entire quantity squared. Now, some derivatives. The derivative of this is 1 plus derivative of that is 0, so that's just 1 times x cubed plus x minus 2, all right? Minus, the derivative of this is kind of ugly. It's 3x squared plus 1, and then this. So x plus 1 all over x cubed plus x minus 2 squared. Now I don't need the 1 out here. This is really just going to distribute through, and I'll have this. And then right here I could multiply through. So this is going to be 3x squared, but then subtract. This will give me 3x cubed. Sorry. This will give me a 3x squared, but then subtract. This will give me an x, but subtract. This will give me a 1, but subtract. So that's what I get there. So let's see, if I combine these together, all of this, I've already taken care of the minus. If I combine all that together, x cubed take away 3x cubed is negative 2x cubed. Let's see, minus 3x squared. X take away x is gone. Negative 2 take away 1 is negative 3. All over x cubed plus x minus 2 squared. All right. All right, let's look at number 15. So they're using some different letters just to make your life happy. Y is equal to v cubed minus 2v root v over v. Now, if I were doing this problem, I would split this up into two fractions and use power rule. That's what I would do. Because quotient rule, although it will work, you do have a quotient, it's going to be a little uglier, I think. So how do we want to do this? Let me do this. V cubed minus, now let's put these together. This is the same as minus 2v to the 3 halves. That's just adding the exponents. This is a 1, this is a 1 half. Add them together, you get 3 halves over v. Let me show you what I mean. I would split this up into 2. Let's make this v squared minus 2v to the 1 half. So that's what would happen if you split this up. And then derivative here is really clean. The derivative is just derivative of that one, which is 2v. Derivative of this one, let's see, the 1 half pops out, hits the 2, it becomes a 1. Subtract 1 from that, so that's v to the negative 1 half. And that's it, you're done. I mean, I think You need to know when the quotient rule is useful, when it's not. In this case, I don't think it is, so I'm not going to use it. Now 17 can't get around it, all right? Look at 17. We have f of t is 2t over 2 plus root t. So I can't split this into two fractions because I have two terms on the bottom, one on the top. So if it were flipped over, we could do it. So I have no choice. I have a quotient. So here's what I'll do. I'll take the derivative. It will be the derivative of the top times the bottom, two terms, so it's in parentheses, minus the derivative of the bottom times the top. I don't need the parentheses, but I'll put it there. All over the bottom squared. And no, you do not just square each one. You have to FOIL it, but I'm not going to. All right, derivative of 2t is just 2. So 2, and then I still have 2 plus root t. Minus, now the derivative of this, derivative of 2 is 0. Derivative of root t is 1 over 2 root t. So 1 over 2 root t. And then I still had 2t over here, right there. Then all of that over 2 plus root t, that quantity squared. And now I'll clean it up. 2 comes through, I get 4 plus 2 root t. And then here, the 2's cancel, and t over root t is just root t. So you're going to get minus root t over 2 plus root t squared. And I can have 2 roots of t, take away 1 root of t. That should just leave me with one of them. So plus root t over 2 plus root t squared. And don't try and do any crazy algebra on that. There's nothing really you can do. Just leave it and you're done. All right. Number 19, x over 2 minus tan x. Two minus tan x. Same story here. You are not allowed to split this up into two fractions. So you've got to go with the quotient rule. So the derivative of this will be the derivative of the top times the bottom minus the derivative of the bottom times the top all over the bottom squared. All right. Derivative of this is just 1, so we're just going to have 2 minus tan x minus, now the derivative of this, derivative of 2 is 0. Derivative of tangent x is secant squared x, but it's minus. So I have minus negative secant squared x. Then I still have an x out here, times x all over 2 minus tan x, which is 2 minus tan x. And then I have a negative becomes a positive. I have an x out front, so we're going to have plus x secant squared x all over 2 minus tan x quantity squared. I forgot to put quantity squared here. That looks good. I'm wondering if we could do some pre-cal stuff on that to make that look better. Sorry. Just hang tight for a second. Okay, sorry about that. All right, here we go. Back on 19, it was simplified all the way. I looked in the back of the book, and that's the way they wanted it, so that's good enough. All right, so quotient rule again here. Trying to get a pattern here. Derivative of the top times the bottom. It's almost like a little jingle. Minus derivative of the bottom times the top all over the bottom squared. All right. Derivative of the top left corner there is going to be negative sine x, be careful with the sign of the sine, times the 1 minus sine x. Don't need a parentheses here because it's a single term. Minus, now the derivative of 1 minus sine x, derivative of 1 is 0, derivative of sine of x is cosine x, but then negative, so negative cosine x. And then times the cosine x again at the end. Then all of this over 1 minus sine x, that quantity squared. Now I'll distribute through this parentheses. I will have negative sine x. I'll have plus sine squared x. And then, look at this. Minus minus is plus, cosine times cosine is cosine squared x. And do you recognize that from pre-cal? I hope so. Sine squared x plus cosine squared x is 1. That's one of the big identities. So I could clean it up a little bit more and put negative sine x plus 1 over 1 minus sine x. Oh, I see something else. Quantity squared. And notice that if I rearrange the numerator, that's 1 minus sine x over 1 minus sine x quantity squared. And that's the same as having something like u over u squared, right? It's the same thing right here. So that's just 1 over u, right? One of the u's cancels. So this is going to turn into, put it down here, 1 over 1 minus sine x. There we go. Interesting that it does that. I just looked at the answer a second ago. I don't remember seeing that. What number was this? Oh, 20. It's not in the back. Never mind. I must have been looking at something else. All right. Let's take a look at... Just want to show y'all something real quick. That answer is just so clean. It's weird that we get that answer from that, right? Our answer is 1 over 1 minus sine x, which is actually less complicated looking than that. So let me just show you something. I'm going to mess with this real quick. I'm going to multiply like this. I'm just curious what's going to happen here. I'm just messing around. No promises that this is going to make things better. If I multiply this through, I did like a conjugate. On the top, I get cosine x, 1 plus sine x. And on the bottom, I get 1 minus sine x squared. That's what happens when I do that. And 1 minus sine x squared, well, that is cosine x, isn't it? Cosine squared x, right? Because we have sine squared x plus cosine squared x is equal to 1. So if I take that to the other side, 1 minus cosine squared x is cosine squared x. One of these cosines cancels, and so I'm left with 1 plus sine x over cosine x. And I can turn that into two terms. 1 over cosine is secant x, and sine over cosine is tangent x. And now if I take the derivative, right? If I take the derivative, this is just y rewritten. If I take derivative, I get secant x, tangent x. That's the derivative of secant x, plus secant squared x is derivative of tangent. And I can factor secant out. Tan x plus secant x. Yeah, well, that doesn't look like the answer I had a second ago. I know it is right, but this is the answer we had earlier. Was it? No, it was minus. So what I could do to convince you that these are the same two answers, this is the same as this, so I could take that answer and I could multiply it by the conjugate again, like this. And then on top, I would get 1 plus sine x. On the bottom, I get 1 minus sine squared x. And that's 1 plus sine x over, remember that turns into cosine squared x. And 1 over cosine squared x is secant squared x. And then sine over cosine x, cosine squared x. One of the sines over one of the cosines is a tangent x. And the 1 over cosine would be secant x, and this is this right here. Sorry, this is this. I was trying to show you that this was equal to that, which it is, you can see. All right, sorry, I'm just going off on, way on a tangent there. I think 21 is enough like the previous two that I'm going to let you mess with it. 23, t sine t over 1 plus t. What was it? Oh no, y equals. T sine t over 1 plus t. All right, you're going to have to use the quotient rule here. The derivative of this will be the derivative of the top times the bottom minus the derivative of the bottom times the top all over the bottom squared. Okay, something interesting is about to happen. Notice in your top left we have to take derivative of this, right? But that by itself, t sine t, if I ask you to take derivative of this, you have to realize that this is a product, okay? So we have to do the product rule on this to figure out what this top left corner is. So I'm like in a separate little problem here, and I'm saying to myself, all right, what's the derivative of this? Well, it's derivative of t times sine t plus derivative of sine t times t. So I'm using product rule on this. This is just 1 times sine t, so that's sine t. Derivative of sine t is cosine t times t, so t cosine t. That is just this top left corner. So this is a quotient rule that inside of it, it had a product rule. So we're starting to combine together multiple rules at one time. All right, so this top left corner is this. So I need it in parentheses because it's two terms. So we have sine t plus t cosine t, and then 1 plus t. And now I can continue. This is pretty clean. Derivative of this just 1, right? Derivative of that 0, derivative of that's 1, and then times this. So I'm just going to put t sine t here, all over 1 plus t quantity squared. All right, now I'm going to clean this up. This is going to be like a foiling in here. So I have sine t plus t sine t plus t cosine t, and then plus t squared cosine t. All right, so that's what I get when I do this. And then I still have minus t sine t. Where am I? Here we go. All over 1 plus t quantity squared. And I do get the t sine t right here and that one to cancel. And so my final result should be sine t plus t cosine t plus t squared cosine t all over 1 plus t quantity squared. All right, 25. Ooh. 25 looks weird. F of x equals x over x plus c over x. So you cannot split this into two fractions. You're going to have to use quotient rule. And a lot of students will look at this c over x and they'll say, hey, I need to do a quotient rule, which I would agree if these were both functions of x, but that's a constant. So I'm just going to rewrite the problem real quick just so you can see where I'm headed with this. I'm going to write this as cx to the negative 1. All I'm doing is I'm bringing that up as up out of the denominator up here as a power. So now it just has a negative power on it. Big deal. I can deal with x to a negative power. So my derivative will be the derivative of the top times the entire bottom plus the derivative of the entire bottom times the top all over the bottom square. Cx is negative 1 squared. Okay, it's not pretty, but it is what it is. All right. Derivative of x is 1 times that thing in parentheses. So I'm going to have x plus cx to the negative 1. So that's this whole thing here. Now this derivative is going to be a little tricky. So let's, I put plus, oops, minus. Now, derivative of x is 1. Now derivative here, remember that's a constant. This is x to a power. So the power comes out. That's going to turn that into a negative c x to the negative 2. But then I still have times x. And then all of that over x plus cx to the negative 1, that quantity squared. And this is, let's see here, x plus cx to the negative 1. Let's distribute the x through. Okay, so the x goes to here, I get x, but then I subtract. And then x goes to here, So remember, we're going to add exponents. This is a 1, that's a -2, and we add them, we get -1. I'll have a -c, x to the -1, but then change the sign. So plus cx to the -1 over x plus cx to the -1 squared. Now these cancel, and I have 2 of these. So I have 2cx to the -1 over x plus cx to the -1 squared. Now, I'm curious to see if that's the way they left it in the back. And one of your goals will be to make it look like the back of the book, just to practice your algebra. Let me see here. 2, 4. This is number 20. Yeah, so I'll tell you what their answer is here. It's really different. So their answer in the back is 2cx, not x to the -1, over x squared plus c squared. And you look at your answer, you're like, whoa, 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 we're way off, right? Well, not yet. Let's see. Maybe we can turn that into this. So let me go back and rewrite this. This is 2c over x, that's what that means, over x plus c over x squared. If you agree, that's what it is, right? All right, now what we're going to do, I'm going to leave that there because I want to try and get to that. What I'm going to do is in the denominator, I'm going to get a common denominator. So look right here. With these two, I'm going to get a common denominator. So look at x over 1. I have to introduce an x on the top and the bottom. So that'll become x squared plus c over the common denominator, which is x now. But all of that is being squared. So I just put these two together. And now, because I'm squaring a fraction, I can actually square the top and bottom separately, can't I? So I can do this. And now take a fraction divided by a fraction and flip it. So when you flip it, the x squared comes up here, and then the x squared plus c squared comes down here, so that's gone. And then one of these x's cancels with one of those x's, and you'll have 2cx over x squared plus c quantity squared. So they are the same answer. I would accept that on a test, but you need to be able to get from there to here algebraically without any trouble. All right, like in other words, that shouldn't be like too far of a stretch for you to go from that to that. All right, 27. I think I'm going to leave 27 for you. I'm going to do 29. On 27, 29, and 31, we're getting back to finding the equations of tangent lines. So now we can find tangent lines, but now we're using a different way to take derivatives. So find the equation of the tangent line to the curve at the given point. So y is cosine x minus sine x. So we could graph that curve, and if we go to the point pi negative 1, so if we plug in pi into this, cosine of pi is negative 1, sine of pi is 0, so we get this point on the curve. So that's where we would be. Now, the question is, what is the equation of the tangent line? The equation of the tangent line. So we need a slope and we need a point. We already have a point. The slope is the derivative, right? So let's find the derivative. Derivative of that's negative sine x. And then here, derivative of that, the minus is here, right? Derivative of sine is cosine, so minus cosine x. So there's your derivative. That'll give you the slope of the tangent line at any point. So let's replace the x with pi in here. So y prime at pi should be negative sine pi minus cosine pi. Sine of pi is 0, we know that, so that's all gone. Cosine of pi is -1, but then make it minus, so 1. The slope's 1. Great. The equation of the tangent line then is y minus y1 equals m, which is our slope we just found to be 1, and then x minus x1, which is pi. So you get y plus 1 equals x minus pi, and then y equals x minus pi minus 1. So remember, this is just a number, right? That's like your y-intercept. The slope here is 1. That's your equation. Graph that line, and it should touch this graph at that point, and it should be a tangent line. Number 27 is a little more difficult. Well, it's the same concept, but the derivative, you're going to have to use quotient rule. And we've done one like that a little bit, so I'm going to let you kind of suffer through that. I am going to look at number 31, which is an interesting problem. You have a weird looking function. Y equals 1 over 1 plus x squared. Yeah. And the graph of this curve is called the witch of Agnesi. And at this point, -1, 1/2. So if you plug in -1 into this, you get 1/2. We want to know the equation of the tangent line. All right, so we need the derivative. Well, this is kind of weird because we do have a quotient, right? We can't split this into two fractions. So I'm going to have to use a quotient rule. Derivative of the top times the bottom minus the derivative of the bottom times the top all over the bottom squared. And notice the derivative of the top is 0, which kills off this whole thing. It's going to go away. And then all you're left with is this. So derivative of this right here is just 2x, but then you're subtracting and multiplying times 1. So you should just get -2x on top. And on the bottom, you have 1 plus x squared squared. So to figure out the slope of the tangent line at this point, I need to find y prime at -1. So let's plug -1 into this. -1 times -2 is 2 on top. -1 in here squared is 1. 1 plus 1 is 2. 2 squared is 4. So I get 4. So I get a slope of 1/2. And so now I can write the equation of the line. Y minus y1 equals slope times x minus x1. There's your equation. Turn that into a plus, distribute the 1/2, and bring the 1/2 over, blah, blah, blah. You've got your equation. All right. Getting kind of burned out here. Got a few more to go. 33. And some of these I need to leave to you to see if you can figure out on your own. I can't show you every single thing. 33. You have f of x equals x squared over 1 plus x, and you're asked to find f double prime of 1. We want the second derivative, and then we want to plug 1 into it. So we're going to have to take derivative of this twice. So the first derivative, we're going to have to use the quotient rule, right? So it's the derivative of the top times the bottom minus the derivative of the bottom times the top all over the bottom squared, which is, derivative here is 2x times 1 plus x minus derivative of this is 1, so minus x squared over 1 plus x squared. Let me clean it up. 2x minus 2x squared, or plus 2x squared minus x squared all over 1 plus x quantity squared, which is